Welcome back to the Off Peak, a video series from Charged Fleet covering a variety of angles on how to electrify fleets and the vehicles and products making it all possible. I'm Martin Ramju, editor of Charged Fleet, and in this episode, we talk with Rob Ferber, the Chief Technology Officer of Exos Trucks, a builder of Class 5 to Class 8 battery electric vehicles. A battery, more than any other component, determines the quality of an electric vehicle. That requires an EV manufacturer to upgrade and improve the durability and range of batteries as much as possible. The bottom line here is they can only get better. We caught up with Ferber recently at the Exos headquarters in Northeast Los Angeles, where the research lab and plant were full of workers handling all aspects of electric truck manufacturing. Rob gave us his take on what goes into a viable EV battery. All right, we're here with Rob Ferber, the Chief Technology Officer of Exos Inc., and he's joining us today to talk about battery technology. Thank you for joining us.
Thank you for having me.
So I'd like to start off, what is unique about Exos EV batteries compared to the others that are on the market?
So anytime someone is buying a commercial truck, the key question is, what does this do to my bottom line? What's the ROI of the product? If you're designing to preserve and improve the economic case of the customer, you're using a fundamentally different set of design concepts than you are for the automotive products. So what's different about our batteries is we start off with a very clear vision of what the commercial sector needs. Our founders are from the sector. And that's very important to me. I live in Silicon Valley. I'm down here every day. And the reason for that is, if you take Silicon Valley mindset to the market and try to sell to truckers, the results are mixed. If you take people from the industry and then bring in the technology you need to make it go, now you're credible in front of the customers that matter, which are the people who buy the trucks. That mindset pervades the entire design of our product from top to bottom. Pragmatism, serve the customer, serve the economic case.
I wanted to get into some of the details of your battery technology. What are some of the patents and some of the innovations that have gone into creating these?
So let me start with heat transfer. Now, if you take a typical electric automobile and you take it to Chicago in winter, you lose your range. The range is down maybe 30%. Mm-hmm. That's because the battery's having to use a lot of its energy payload just to keep itself warm. Now, as a person, you or I going to Chicago and stepping out in winter probably are going to put on a coat. Mm-hmm. We're not going to wrap ourselves in nichrome wire and carry around a car battery. Mm-hmm. But that's what the electric car batteries are doing. If we did that in the commercial vehicle space, you'd have this fundamental problem that, can we do our route today? Let me check the weather. That doesn't cut it for commercial customers. You need to be able to do your use case day in, day out, rain or shine, hot weather or cold weather. Your range needs to be insensitive to the environment. We have done an entire series of technologies and innovations that accomplish that. So we're an automotive product, and most of them kind of have the same form factor as a cell phone. Mm-hmm. They're flat. They've got a huge surface area. Heat leaks in, heat leaks out. If you actually insulate an automotive product, it gets thicker. You lose leg room in a car. People notice that. Well, trucks have a lot of marginal spaces that aren't utilized. We have enough space where we can put in some insulation. It doesn't have to be much. And now we put a coat on the battery. Then we add our heat pump. Now we're the gatekeepers. So this works in extremely hot places like Las Vegas in summer, or in cold places like Chicago in winter, where we're strongly decoupled from the environment. And our heat pump is moving heat in or out of the battery related to what we're doing. And that gives you a range that is insensitive to the environment. And we've demonstrated this. We have the same product we deployed in Los Angeles, and we deployed in Chicago. And it did take a lot of math to find the difference in the range. And there was an impact on the range being in Chicago. It was in the third decimal place. Mm-hmm. We're proud of that. But this is the kind of innovation that is both very simple. We're using a urethane foam insulation. It's cutting-edge 1954 technology. But we're using it in a very innovative way. And this means it's also low risk. There's no mystery as to how it's going to perform, because we've got the better part of a century's track record on these particular materials. We know exactly how they're going to age, degrade, and handle a wide range of edge cases, which means we can go to the customers and say, you'll get this performance. No, really, because here's the data and here's the track record.
Now, looking at the last 2 years and with battery technology evolving so rapidly, what have been some of the advances since we last reported on your company 2 years ago? And what is there to look forward to in the next few years?
So, most of the advances relate to two areas. How much energy do I get per unit volume? In other words, how much energy can I pack into the picnic cooler? And the other one is longevity. How long will this thing last? Now, it's funny, cars will have a certain lifespan, at which point out of warranty, and you can now figure out on a vehicle by vehicle basis if you want to keep it in service. Commercial trucks have a primary financing period, a primary lifetime, and that is many, many multiples of the automotive lifestyle cycle in terms of, or lifespan, in terms of duration and miles. So you want to make sure that these things last for a very long time. So that's very interesting to our customers. There's been a lot of press about the improved safety of certain products. But ultimately, the safety of anything that stores energy is a matter of engineering. If I walk in here with a bucket full of gasoline and put it down, it probably does nothing to your stress level, at least nothing good. Batteries, gas tanks, anything, compressed air, they all store energy. It has to be done correctly. You put engineering around that to make it safe. So having safe cells does not make a safe system, and that is a common misconception. I like safe cells, but the job is always to make the safe system. And that turns out, some of the things that make a cell safe in consumer electronics may make it dangerous in a vehicle setting. It just depends on what are the failure modes, and what happens if I'm in a 700 volt stack versus a 4 volt stack, and what are the differences? What if I'm drawing half a megawatt versus 200 milliwatts? The same cell may have entirely different safety profiles in those two things. So we are seeing a lot of hype and a lot of honest, earnest work going into designing economically superior cells. Part of that's safety, part of that's energy density, part of that's power density, and part of that's lifespan. I don't see a winning horse yet. The old style lithium ion batteries are still the front runners and are, as far as I can tell looking forward, going to be for the next several years. Solid state batteries, while very promising, most of the ones that I've seen that have actually claimed to be functioning, commercially viable solid state batteries, they've had to mess with the definition of what's solid state. Oh, well, we've put a sponge in there that's holding the electrolyte. So it's not a solid, it's a liquid. Well, there's a solid, it's the sponge. That's not quite what people were aiming for. So I do see a lot of sincere, creative, effective work going into developing new batteries. But I see a lot of the areas that are being successful relating to things like, how do we get heat out of the cell? That's your first battle with the lithium ion battery. That's your first battle with any battery, really, is how do I keep it all at the same temperature? How you move heat around inside the system and inside the cell is actually very important. So we're seeing some of the innovations, such as the new larger Tesla cell, where they basically took the heat sink and stretched it up into the cell. We're seeing some of the blade cells from BYD that are interesting. We have our own pieces of this puzzle, but can't go into too much detail here.
You touched upon lithium ion versus solid state. Should solid state be on the radar screen for commercial battery applications in the future? Is there a timeline where that could become something really viable?
So yes, it should be on everyone's radar screen. Is there a timeline for it to become viable? That's much more a matter of opinion. Here's one of the tests. Show me who's breaking ground for the 1,000,000 square foot factory that can produce 50 gigawatt hours or more a year. The moment they break ground for that, you're 24 months from commercial deployment. So you can start counting backwards. I don't see any of these factories, not really. So that tells me we've got at least that much lead time before these things come into play. Now, I'm a scientist. I did my doctoral work at Caltech. I'm a chemist. I get a lot of people contacting me, and people I ask questions of who are working in this space, and I don't see something right now that I'm going out and putting my own money into investing in. It's like, oh, I got to get onto this ride with the solid state. I see a lot of people making good incremental progress, but no radical breakthroughs, not yet.
Could you give us an estimate or a sense of the timeline for Exos batteries decreasing in weight and increasing in power capacity? We keep reading in the media about how batteries are getting lighter and longer range. What's a realistic timeline for that, in particular for commercial battery applications?
So Exos has a cadence of releasing products. We've got, for certain elements, and that includes the battery, there's exceptions, we do some things out of order sometimes, but of once a year. This is in part because you have to do testing and validation, and then you have to stand up the manufacturing capabilities, the supply chain, and then you've got to train the people on the production line what's different. So there's a certain latency to bringing a change, even once it's technically ready, to being manufacturing ready. And so right now we're putting a cadence out of about one major revision per year. We could do more, and we may do more this year, but that's the basic cadence. At the same time, commercial vehicles, our trucks are already essentially at mass parity for their internal combustion brethren. So we're not paying a penalty. We can make them lighter, and there's benefits to that. But honestly, most of the energy that goes into a commercial vehicle's drive cycle doesn't have much to do with mass. It has to do with the sail area of the vehicle and the fact that you're moving a lot of air out of the way. And that takes a lot of energy. So the gains in efficiency of the vehicle from mass reduction are somewhat limited. You do get more payload. It's called payload for a reason. It's what they're paying to carry. So it's always good to decrease the mass of the battery in other systems. But it's not a fundamental enabler. It's not we're waiting for this to be commercially viable. We are taking internal combustion systems off the road in unsubsidized markets today through simple economic competition.
Rob, I know there's so much more we could talk about in the field of technology. Certainly hope that we'll have you back. But thank you very much. It's been very interesting.
It's been a pleasure being here with you. Thank you for the opportunity.
All right. A special thank you to Rob Ferber, CTO of Exos Trucks, for his insights on the potential of EV batteries. Let us know down in the comments any of your thoughts or views about the performance of EV batteries in your fleet, no matter where you are in your fleet transition. Please remember to follow and connect with us on social media, subscribe to our YouTube channel, and sign up for our weekly Charged Fleet e-newsletter to stay up to date on the latest industry news and episodes of The Off-Peak. I'm Martin Ramju with Charged Fleet. Thank you for joining us, and we hope to see you again here on another pulsating episode of The Off-Peak.